In this video, we must learn how to convert fractions to decimal form. Recently, we looked at dividing fractions, where we considered, could this piece fit into that part, and what fraction of this amount could fit into this part. This is the link to understanding how fractions can be converted to decimals. Because when I look at this fraction, what I'm really wondering is, does 2 fit into 1? The same calculation could be shown as this. Does 2 fit into 1? And clearly, it cannot fit 1 whole time. So we can also use a simple short division calculation and consider, does 2 fit into 1? Clearly it cannot, but when I introduce the decimal point and a 0 and question, does 2 fit into 10? It fits 5 times. And in this way, we can conclude that 1/2 is equivalent to 0.5, or half of 1 whole, as a decimal value. What you've just seen is an example of a terminating decimal. This means by doing the division, there's a definite ending to the decimal value. In other words, the digits in the decimal column will not go on endlessly. If a fraction is not a terminating decimal, a fraction gives either a recurring decimal or a non-terminating decimal. Lots of these we can learn by memory, and we call them conversion facts. Make it your goal to memorize each. Look at the group of terminating decimal values. Notice the group of recurring decimal values. Let's look more closely at each type. Terminating decimals. The fraction 4/5 gives the terminating decimal 0.8. Using short division, what we're really asking is, does 5 fit into 4? Which we understand is also expressed as this, and can therefore be solved all of the eighths give terminating decimals. For example, 7/8 is asking, can 8 fit into 7? We can calculate this using short division. Can 8 fit into 7? Clearly it cannot, so we introduce a decimal point and a 0. Can 8 fit into 70? Yes, because 8 eighths are 64, but there is a remainder. Introduce another 0. 8 eighths are 64. That means the remainder up to 70 is 6. Can 8 fit into 60? Yes, it can 7 times, because 7 eighths are 56, but there's a remainder. Introduce another 0. The remainder is 4. Now we're asking, can 8 fit into 40? And the answer is exactly 5 times. So 7/8 gives a terminating decimal. This value has a definite ending, 0.875. If the digits in the decimal columns do go on endlessly, then they could be an example of recurring decimals. 1/3 and 2/3 are examples of recurring decimals. Using the example of 1/3, what we're really asking is, does 3 fit into 1? So we can use short division to ask the same question. does 3 fit into 1? Clearly it cannot, so we introduce a decimal point and a 0. Now we're asking, does 3 fit into 10? It can fit 3 whole times with 1 remainder. So we introduce a 0 and we ask, does 3 fit into 10? And the answer is 3 whole times with remainder 1. So we introduce a 0. And we ask, does 3 fit into 10? And the answer is 3 whole times, remainder 1. So we introduce a 0. And you can see a repeating pattern. This is called a recurring decimal. Here's another example of a recurring decimal. Does 9 fit into 2? We can also solve this using short division, where we ask, does 9 fit into 2? Clearly it does not, so we introduce a decimal point and a 0. Now we ask, does 9 fit into 20? And it fits 2 whole times, remainder 2. So we introduce a 0. And we ask, does 9 fit into 20? And it does, 2 whole times, remainder 2. So we introduce a 0. Now we ask, does 9 fit into 20? And it does, 2 whole times, with a remainder, and so on. This is another example of a recurring decimal. Recurring decimals can either have a single repeating digit, like we've just seen, or a repeating series of digits. For example, 1 on 7. Instead of using short division, I'm going to show you on a calculator, because 1 on 7 can also be 1 divided by 7. At first glance, it looks like a random series of numbers. However, notice the repeating pattern. The digits 1, 4, 2, 8, 5, 7 go on to repeat. It's just not all displayed on scene. That's why this is also an example of a recurring decimal. To finish, there is an example of a decimal called a non-terminating, non-recurring decimal. It goes on endlessly, and there are no patterns that repeat. The most famous example of a non-terminating, non-recurring decimal is pi. That's the fraction 22 on 7. It's commonly referred to as 3.14. This is a whole number and decimal approximation. In other words, it is this value rounded to 2 decimal places for convenience. Pi is a very famous decimal fraction which never repeats and never ends. A question you might be wondering, how can I know if it will give a terminating or recurring decimal? The terminating decimals are any fractions over 2, 4, 5, and 8. And the recurring decimals are any fractions over 3, 6, 7, and 9. To make life easier, mathematicians have a way of writing down recurring decimal values. We write a little note above the digits. This is called decimal notation. If there's a single repeating digit, we place an obvious dot above the digit that repeats. Do not repeat the digit when you use decimal notation. Just write the repeating digit once and then the dot. If there is a repeating pattern, we collect the pattern with a line above the digits. Simply write down the repeating series once and write the line above the digits.